Alright, hello there. We're going to look at a little bit of C++. So we have some example files in this directory, and we have some notes at this link. And here, which we'll be sort of adding to, potentially. So your background is that you've already done C programming, and now we're switching to C++, and what is different and what is the same. I guess we could add in here the same. Everything in C works in C++, mostly. Okay, so for loops, for, while, if, etc. All right, all that stuff. All that works the same, and then we're going to just add more ways to do things. Okay, for us on Linux here, we're using GCC to compile C and G++ as the shorthand for compiling C++. All right, and we're normally calling C++ files.cpp. What else do we have in here? Okay, so all this stuff works the same. That including standard library of printf, fopen, strcmp, isalpha, whatever. All that stuff that you use in C will still be able to use. There's a C, for some of those things, there's a C++ way of doing things. Instead of printf scanf, we'll have cout cin. There's a thing called a namespace, which we'll use. Okay, just to give you a preview of things that we want to look at. In C, struct is a way to make a new data type that combines a bunch of variables together. We've been having struct for our data structures, linked list, hash table, binary search tree. In C++, you can still do that if you want to, but the C++ way of doing things is called a class, which is kind of like a struct, but can do more. So struct just has some data items together. Class has some data items together and functions for those data items, and you can make multiple copies in different ways. That's cute. Basic data types. We now also have bool as a data type for true or false. So we still have everything as an integer and characters. Now we also have something called bool, which we'll see in one of the programs. There's something called string, which we can use instead of C strings. C strings are char star or char array. There's a little bit about strings here. Okay, operator overloading is something we'll be able to do with our new class data types. We can change what the operators like plus or minus or less than or whatever do for our new data types, and we'll see examples of that. Okay, there's something called pass by reference now, which we'll see, that allows us to have a function that changes the variables that are passed into it. In C, we have to use pointers. If we're in main and we call a function and we want that function to change some variable in main, you have to do it with pointers. In C++, there's pass by reference. And there's templated functions and classes, which we'll see. An overriding theme here is do we want more code reuse? and less typing. Okay, so more code reuse. So as an example, we only write, let's say, binary search once. Okay, so even though we're going to do binary search for different types of data, maybe it would be nice if we just write that algorithm only once and we could reuse it with different data types. In C, you can sort of do that. In C++, you can definitely do it, and that's kind of part of the whole idea. All right, let's get to looking at some of the examples here. Starting from the most simple, I believe input-output is our first simple example. So these programs are already there. I'm just going to sort of point at them and compile them and run them. Let me compile this one first. Okay. I have something that should have been a comment there. Hello, this is a message. Type in integer 45. Okay, 45 plus 45 is 90. All right, now the code. We have pound include IO stream input output stream. So IO stream is the header file for cout and cin. I have a note here. So on this particular part, in C, if we wanted to print, type an integer, we would printf. In C++, we have cout with the less than. Okay? So that is that. If in C, if we wanted to read an integer now from the keyboard, scanf, %d, and the address of x. In C++, we have cin greater than x. So instead of printf, we have cout. Instead of scanf, we have cin. We could still do printf scanf if we pound include stdio.h. All right. So you could pause if you want to on this. Cout cin. About cout, you can string multiple things together. So I'm going to output x, and then I'm going to output the string that's there, and then I'm going to output x again, and then I'm going to output equals, and then x plus x. So something to notice here that's cool is we didn't have to tell cout what x is. X is an integer. So in printf, you have to tell it %d. I'm an integer, a decimal integer. So cout in C++, it'll automatically do the right thing. So this is a string constant right here, and that'll print as a string constant. X is an integer, so it'll get the integer value of it, and that should go on our list somewhere. Let's just put whatever somewhere. Cout cin. So something nice about those, they do type checking for us. That's great. Don't need in general. Sometimes you will. So don't need %d. Plus nodes or something. All right. So that's a difference. That it may be that you could avoid some mistakes this way because it'll automatically do that conversion. All right. There's something else in here. There's this using namespace std, and namespace is a new thing that's in C++ that allows you to group together a bunch of functions and variables. So by default, everything that's coming out of the standard libraries, so IOStream is in the standard libraries for C++, everything by default, including the cout, is in a namespace called std, and if I want to use it, I would do this, including this end line name there. Don't need to do it for int because that is not coming out of the standard libraries, that is part of the language itself. So I would need to do all of these. Couts, cins, and end lines. Those are all coming out of the standard library for C++. Okay, it compiles. If I didn't have them in, let's go back. Okay. I get an error. Cout was not declared on line 9. Suggested alternative, std : cout, which is what I had before. Okay, so by default, all of these functions are in this thing called a namespace where you have to put the name of the namespace and : before it. What's the reason for this? One reason would be so you don't have different packages interfering with each other in the names of their functions or variables. So what if I wanted to have a function called cout or an integer called cout? I could do that. I could have int cout equals 3 or something like that. And that cout is different than std : cout. Alright, so that adds some flexibility that I can have it if I want it. I am lazy, I don't want to type that. So I will do this, and that takes everything that is in the standard libraries and makes it so that they are available to me. That also means that I can't now have a function called cout or a variable called cout in my program. I'm okay with that. Alright, that's our first program. If you want to see it more, then pause. We go into another program to look at. Why don't we do data types? All right, and then in here we have an example. We have IOStream, we have string, we have some meaningless comment that we can get rid of. Notice that I do not have a using namespace. So this file, I went ahead and did it with the, putting the std : in there all the time. That you'll see code like that. You'll see it both ways. Neither is right or wrong. They're just different. All right, so here we see the new data type in C++ bool, which is just lowercase letters. And then you have the two constants, true and false, not in quotes. So true and false, not in quotes, that's a special thing that means true and false. All right, and then I had a test here. X is set to false. First it's true, now it's false. We're going to print it. What do you think we'll print? The reasonable things for it to print would be either the word false or maybe a 0, because 0 often means false. X is false, and it prints like there's the 0. All right, and then we can use the Boolean values in if tests and while tests and for loop conditions, anywhere that we would have something that's true and false stuff. Okay, and here I was testing out that we, at least with options I'm using right now, it does let me, even though X is a Boolean variable, it does let me put things into it like 0, 1, 1, 2, 3, and H. And you could ask here, what is the value of X? If I try to put H into it, and it's something that's true, why don't we put X is so we can see what that prints as. All right, I need to put my std : in there. And after I tried to put H into it, it has the value 1. So that's kind of like, yeah, that's kind of normal for programming, that anything other than 0 is true. It's actually not saving the letter H, it's saving true, which is 1. Okay, so that's bool. That's a new data type. We have another new data type, string, which is actually part of the standard library. So we have to do the pound include with string. Okay, so we have something called string, and then we can put in there something in between quotes. In C, we would have had to do something like char name bracket 100 equals Jeff Kinney or something like that. So there we allocated 100 characters, and then there it is. In C++, we have a string. We don't have to tell it how many characters. It'll make sure there's enough. And then cout understands that if we put a string variable, there it is. Okay, something that's new with string is string concatenation. Does this with the plus, which is kind of cool. In C++, we would have to do something like, well, there's different ways to do things. strcat is one. So there's a function where we concatenate destination onto the source. So I guess we would do in C strcat name aka blah. Alright, so there's a function that we could call that would take this string here and add it to the end of that. In C++, we can say this. Alright, so the plus will put these two together, and then the equals puts it back into name. That's overloading the operator plus. So for strings, if we have a string that's involved with a plus, it actually does concatenation and not integer stuff. If we tried to do this in C, it would say there is a pointer. This actually is an address of a spot where this is kept, and it would just add the addresses, which is probably meaningless. Alright, so we have bool and we have string. Let's take a look at another one of these files. Let's look at pass by reference. Alright, let's look at this. So ignore everything. Look here first. Alright, if we wanted to do a swapping of variables in C, we're down inside of main, and we had int x equals 1, y equals 3. That's what we have down here, but so we can just look in one place. If we wanted to switch the values of x and y, we would do something like this. Alright, so we have x and y. X is 1, y is 3. I pass in to the swap function the address of x and the address of y. So this n1 is pointing back to x, this n2 is pointing back to y. If I do int temp equals star n1, that says go follow the pointer, and what's the value? The value at x is 1. Okay, so star n1, that says follow the pointer. Right, x is now going to be the value of, okay, n2 points to y, so that's going to be 3. Okay, so this sets x equal to 3. Now this sets y equal to 1. Back in main. And the reason that this changes the x and y back in the main is because you pass the addresses in, and inside the function you follow the pointer back. If I had it declared like this, then that would do something. It would change the n1 and the n2 variables, but those are local variables to this function. It wouldn't change x and y. Okay, so like this, the change stays inside the swap function. It doesn't go back into main. If we want it to go back into main in C, then we have to throw these pointers around, which is okay. We end up typing a bunch of stars. Here's the C++ way now down here. You can still do it this way if you want to. Everything that you could do in C, you can still do. All right, so down here we have the function without the stars. Okay, so what we want is temp is going to be n1. We're going to switch the values of n1 and n2. And if we want those values to go back to main, then all we have to do is put an ampersand here, which means pass by reference. So pass by reference means the values, so when the function is called, it's not just the values that are going in, it's a reference and address of. So it's really doing this address of business, but we don't have to type all the stars. We just have to type the ampersand once. This is less typing. All right, so the thing that you have to remember is if you have a function, you wanted to change the variables back wherever it got called, you have the ampersand for pass by reference. Now that is also something that you need to keep in mind when you're looking at other people's code. If you see something like this, there's a possibility that that function actually changes x, even though in C you would see them passing a pointer, and then you would know. C++, you have to go and look up the declaration. It doesn't have an ampersand there. Okay, that's called pass by reference, and that should be on our vocabulary list somewhere. Pass by reference. Okay. The normal way is called pass by value. The value is passed in versus reference is another name for address, memory address. Okay, there's pass by reference. Now we go to classes. Let's see, what's our time? We'll keep going. Okay, classes.cpp. Let me run this first. Okay, so we have a printout here with Guinea Jeff and dog pet unknown. All right, so what this example, let's go to main. So we always start here in main. Let's just kind of trace through what's happening here. So what happens on this line? Person T, P1, P2. Okay, so P1 and P2 are some type called person T in C. This would have been defined with a type def, probably, and a struct. In C++, we have P1 is a class. Okay, so in C, you could have something like this. There's a struct. It has last, first, and years. So here we have a class, last, first, and years. That's the same. We have this public, which I don't want to say anything about. It's just there. You have to have it. All right, so that's just like C. I have P1 and P2. Each one has a first and a last. I can use P1.first, P1.last, P1.years, just like in C you could use a struct. Okay, something new is now that P1 can have its own function. So you can sort of do that in C, but not like we're going to do here. Okay, so P1 dot print, what that's going to do is it's going to look for the print function inside of the P class and run it. Okay, so what happens when we get there? We do a cout, and it does last, first, and years. Where does it get the last? Where is the last variable coming from when it was called down here? So P1.print. We're inside the print function. Okay, so the nice thing is when you're inside the P1 print function, last means the last of pre1. First means the first of P1. So when I'm inside of P1.print, last, first, years are P1's copies of those. Okay, so I could have had a P2 here, and if I do a P2.print, it's the same code here defined, but then it would be P2's copies because P2 has its own last, first, and years. All right, so this one here has there's another class here, animal type, and that's fine. It has a species, gender, and is it a pet, yes or no? Okay, so that's just the first look at class is that classes are like structs. They can have their own functions, which is nice. There's a lot of other stuff that we'll do. There's a lot of rules, but that's the first look. They're like structs. They're a way to have a bunch of variables together, and you can also have functions with them. All right, now let's look at data structures. Okay, let's run this, and we can see what it looks like. This is going to read from standard input for some amount of time. Why don't we do, okay, so type stuff, control D, so 1, 2, 3, 4, A, B, control D. So this is what I typed here. Now it prints B, A, 4, 3, 2, 1. It printed it backwards. So if I want to print something backwards, I kind of have to remember it all. So if I was going to write a program to do this, take whatever they type, remember it all, and then print it backwards. So in C, you would read this into an array of strings, and then you need to allocate enough space, enough strings so that it would be okay. Maybe you'd have to deal with reallocating things in the middle if you know how to do that. But basically, you need to read this into an array. You're going to have some kind of loop that's like while scanf %, maybe you're limiting your strings to be 99 characters to prevent buffer overruns or something like that. So while scanf equals 1, then you would store it into an array. So maybe you have to copy that A bracket I. If A is an array of strings, and you have enough room in it for this string. Okay, you might have something like that, and now if you want to print it back, and I guess I++, right? If I is keeping track of which one we're at. Now if we want to print it in reverse order, it could be something like I is greater than or equal to 0, I++, printf %s, AI. Something like that. Okay, maybe we need to subtract 1 initially. So this I starts off being 0. Okay, so I starts off being 0. We read a string as long as we can read a string, so scanf will return 1. We save that string with strcopy into some array that we've declared. Hopefully we've declared it with enough space so that it'll work out. And then after we've read it all in, scanf will return 0 eventually, or -1 or something. Then we're going to go through and print these off from the last to the first. Okay, so that's what the C code would kind of look like. And this all uses an array A of it uses an array A, which we'd have to declare somehow. So A, maybe there's 1,000 of those, and each one has room for 100 characters or something like that. Okay, so now we want to look at the C++ code. We're using something called, let's go to, okay, so we'll skip straight to the main loop here. So the main loop here in my C version, I had while scanf %99s s equals 1. Okay, so that was my C version of a condition to read a string repeatedly. In C++, we have cin, so we do cin, we read it into S. As long as that's okay, the condition will be true. And over in my C part, I had strcopy a bracket I, S, and I++. Okay, so we are dealing with this a bracket I. Over here, we have something called words. That's instead of a. So I have words. The type of it is here. It's a vector, and vector is basically an array that can grow in size. Okay, so we can use it like a bracket I, like that. We can use words bracket 0 and stuff, but we don't have to worry about how big does it need to be. Okay, the code inside the vector class will take care of that. Alright, and it's a vector of, this here is our first example seeing a template. A template means that we can have a vector of strings, or we can have a vector of integers, or booleans, or any other type that we have. Alright, so something that is templated, we have to give it a type in between these less than, greater than. So we have a vector of words, of strings. And the vector, if we go over to C++ vector, we'll find some site or other. This is a sort of description of the class in general. I said that pushback is something that I was using there. So we can look, this is a description of a particular function inside the vector. And there's an example code. On C++.com, these example codes are normally pretty short. And just a quick look at how you would use the function. So here we compound include the vector. They have a vector of what type? Integer, so my vector there. They have saying they're going to read some integers, so there's a myVector.pushback, my int, and then they have something called the size of the vector, which has how many. Alright, over in our example, pushback adds to the end of the vector. Dot size is how many things are in the vector, so words dot size. So if they typed 3 words, words dot size is what? It would be 3. However many words they typed. They each get pushed back into the vector. So the last index, if you have 3 items, the last index is 2, because you start at 0. So we go starting at the last index, greater than or equal to 0, minus, minus, and each time words bracket I is that particular item in the vector. Okay, so what's the point? The point is, here is an array. We don't have to worry about what the size is. It'll grow as we need, which is neat. In C, we could do that. We'd have to make functions to do it. In C++, we don't have to. It's already defined. And we can store whatever we need to in there because it's templated. We give it whatever type we want when we declare the vector. That is cool. Files, store. You probably should have paused by now, if you haven't already. There's no way you could watch 35 minutes of this without falling asleep. Alright, so this is a simple program to read a file. You see the usage statement there. Give it a file name. It's just going to print, so it's reading one string at a time. and just printing them off with spaces in between. So if I give it the files.cpp, this is the first string, there it is. This is the second string, there it is. Third string, so it's just putting spaces in between each of the strings of the text file. All right, so there's the usage statement. The new thing here is if you want to do a file in C, we could do fscanf. That's like scanf, but coming out of a file. In C++, we would do something instead of cin. Cin is IOStream, coming out of IOStream. The file version is coming out of fstream, F for file. All right, and here, instead of having while cin greater than s, so that would read from standard input, instead of that, we can put a file input stream that we've set up. So the file input stream, here we declare file input stream variable, fin, and here we open the file argv bracket 1 for reading. Okay, and how do we know that it's been opened for reading? Because this is the input file stream, and that's the rule for input file stream. Alright, so we have our file variable, we've opened a particular file, whatever they gave on the command line, and then we can use that fin just like cin. So if we want to read numbers out of it, whatever we want to do, we can use it just like cin. Eventually, this attempt to read a string will fail, and that will be false at the end of the file. So there's your first look at a file. If we wanted to output to a file, we would do like cout, and instead of an output file stream, instead of cout, we would use an output file stream. So we could put ofstream fout.open. Maybe we want to do string file name equals argv bracket 1, file name plus equals dot new or something like that. Okay, so now we could do file name dot c underscore str, I believe. Let's see. And then I could write here fout. Right, so we're putting it to the screen, and this would also put it to that file, which would be the original file name plus .new. Now there's a new file called files.cpp.new. This just has that in it. All right. So that's input file. Is if you want to read from a file, you have an IF stream. You have to open it. You use it like cin. If you have an output file, you have to open it. There's the open, and then you use it like cout. Okay. That's files. Operator overloading, I think, is our last example. From introducing some of the stuff you can do with C++. Let's go down to main. Okay, so we have some data type called rational. Here is rational, so class rational, public. There's a top and a bottom. So what we're thinking of is fractions. So 1/4 has top 1 and bottom 4. Alright, so what I'm thinking is we're doing a fractions. So we have a fraction 1/4. Then we have a fraction 1/3, because we put 1 on the top and 3 on the bottom. 1/4 and 1/3. Okay, we have a new rational. This says Q3 is what? 1/4 plus 1/3. If you add that up, this is 3/12, and this is 4/12. Add them up, you get 7/12. So this Q3, if you just do it on paper, kind of, then you would get 7/12. Let's see what the program does. One-fourth, 1/3, 7/12. Now the question is, how does that actually happen? I have a variable Q1, Q2, Q3. They're rationals, which I defined a class. And the class is like a struct. It has its own data, a bunch of different variables, and maybe it has some functions. Okay, but what does it mean to say Q1 plus Q3? Normally, plus means you're adding integers. But now we've seen with strings, something different happened. And the way that it actually happens is called operator overloading. Okay, what operator overloading means is if you have a new class like rational, we can change what the plus does. The plus would do by default adding integers, adding memory addresses, or something like that. If we wanted to do something else, we wanted to look at these as fractions. Okay, so here it is. The rules in C++ is if you're inside the definition of a class and you say operator plus, so keyword operator then plus, you can change what it does. Okay, so the rule is if I do Q1 plus Q2, then what it's really doing a function called operator plus, and it's doing it inside of Q1. So it's going to do Q1.operator plus Q2. That's what really happens in C++ when I say Q1 plus Q2. Alright, so if this is what's going to happen, I know I have Q1, there it is, so the parameter has to be the right hand part of that plus. So there it is, I called it right. So this is the plus function for rational. Okay, so there's a rational that's going to be the right hand side. I'm going to do a plus, it's going to return a rational. Rational is something I write this new class I'm defining. So I'm going to make a new rational, do the arithmetic. So this is doing the fraction stuff, just whatever. You can review that if you need to, and then return it. Alright, and I can do this with just about any of the operators. I could change what it does for rationals. Or whatever data type I'm defining, I could change what the operators do, which is cool. Okay, so this will become a new rational value that has 7/12 inside of it. If I want to save that into Q3, this is an assignment, but it's happening with a rational, so I probably want to say what that means inside my class. So I can say what the equal operator actually does. If I have a rational on the other side of the equal sign, I copy the top from the rational into me, copy the bottom into rational into me, and then this thing. So return star this. Okay, so that's enough I think that's enough look at that to give you an idea. All right, when we define our own new data types with classes, it is within our, it's in the rules or whatever that we can change what the operators do if we want to. All right, I believe that is enough. So what you should be doing is waking up. Probably want to go to some tutorial. So for example, C++.com has a tutorial. This is good stuff. It's pretty basic level. Do that and have fun.